Imagine for a second something from another star system screaming through our cosmic neighborhood at a speed that just shreds the rulebook. This isn't science fiction. These things are real. They are interstellar visitors, and they carry the secrets of their home worlds light years away. For decades we figured they had to be out there, but we'd never actually seen one. Then we found one, and then another, and then a new one that blew the others away. Every single time, it's a desperate race against the clock, a frantic scramble by astronomers to point every telescope they can at these fleeting messengers before they vanish back into the void forever. The latest visitor is an object moving faster than any natural thing we've ever recorded, a true alien comet that just shattered our solar system's speed records. So, what is it telling us, and what are we learning from the ones that have already passed us by? The answers are challenging everything we thought we knew about the universe. Our story of finding these cosmic nomads begins on October 19, 2017. An astronomer named Robert Warwick, using the Pan-STARRS telescope in Hawaii, spotted a faint point of light moving across the sky. At first, it looked like just another asteroid, but as his team tracked its movement, a startling reality began to sink in. This object wasn't looping around our sun like everything else in the solar system. It was on a one-way trip. Its path was a perfect hyperbola, a specific kind of open trajectory that proves an object is moving fast enough to escape a star's gravity. In other words, it came into our system so fast that the sun's immense gravitational pull could only bend its path, not capture it. It had come from interstellar space, and it was heading right back out. This was humanity's first confirmed contact with an object from another star system. They gave it the Hawaiian name Oumuamua, meaning a messenger from afar arriving first. And here's the catch. By the time we even spotted it, it was already leaving, having passed its closest point to the sun 40 days earlier. The discovery sent shockwaves through the scientific community. It was historic. But this messenger was weird. It was small, probably only a few hundred meters long, and it was tumbling end over end. Weirder still, it didn't look like a comet. There was no visible coma, that fuzzy cloud of gas and dust that envelops a comet when the sun warms it up. It just looked like a dark, reddish, and incredibly stretched out rocky object. But then, it did something that asteroids just shouldn't do. It accelerated. As astronomers precisely tracked Oumuamua, they saw it wasn't slowing down the way gravity said it should. Something was giving it a tiny extra push, what they call non-gravitational acceleration, speeding it up on its way out. This is totally normal for comets. When ice vaporizes and shoots off the surface, it acts like a faint rocket thruster. But Oumuamua had no visible gas jets, no coma, no tail. So what was pushing it? That's where the real mystery began, a puzzle that still sparks intense debate. As Oumuamua slingshotted around our sun, it hit a blistering peak speed of 196,000 miles per hour, or about 87.7 kilometers per second. Once it was back in deep space, it would slow to its original interstellar cruising speed of about 59,000 miles per hour, but its acceleration remained the true anomaly. Then, just 2 years later, it happened again. In August 2019, an amateur astronomer named Gennady Borisov spotted our second interstellar visitor. This one, named 2I/Borisov, was completely different. It looked and behaved exactly like a comet we'd expect, with a clear coma and tail. It was a dirty snowball from another star. And it was fast, clocked at a peak speed of around 100,000 miles per hour as it rounded the sun. For a while, Oumuamua held the record. But then, in July 2025, everything changed. A new object, designated 3I/ATLAS, was spotted entering our solar system. And this one is a true record breaker. As it passed its closest point to the sun in October 2025, 3I/ATLAS reached a mind-boggling speed of roughly 153,000 miles per hour. That makes it the fastest natural object ever recorded passing through our solar system. For all three of these visitors, their discovery triggered a frantic global campaign. The clock was ticking. These objects weren't just fast, they were temporary. Once they passed a certain point, they would be too faint and too far away to ever be seen again. It was a race, a limited time opportunity to learn everything we possibly could. Astronomers scrambled for time on the world's most powerful instruments. The Hubble Space Telescope was quickly pointed at all three, capturing crucial images. For Oumuamua, Hubble's precision tracking is what confirmed its bizarre acceleration. For Borisov, Hubble revealed a nucleus about the length of 9 football fields and a tail 14 times the size of Earth. On the ground, massive radio telescopes like the Atacama Large Millimeter/Submillimeter Array, or ALMA, analyzed the chemical soup coming off comet Borisov. The findings were stunning. ALMA detected a huge amount of carbon monoxide, far more than any comet seen at a similar distance from our Sun. This was a profound clue. Carbon monoxide ice only stays solid at incredibly cold temperatures below -420 degrees Fahrenheit. This suggests Comet Borisov was born in a very, very cold place, maybe around a dim red dwarf star or in the absolute coldest edges of a planetary system totally unlike our own. By the time 3I/ATLAS arrived, teams were even more prepared, using data from Mars orbiting spacecraft to help pinpoint its trajectory with 10 times greater accuracy, a critical advantage in studying such a fast-moving target. This is the incredible power of these visitors. They are direct samples, pristine relics from the planet-forming nurseries of other stars. By studying them, we aren't just learning about a random rock or snowball. We're doing remote archaeology on a star system we may never reach. While 2I/Borisov and 3I/Atlas were somewhat familiar, if chemically strange comets, Oumuamua remains a profound enigma. Its bizarre list of properties, the extreme shape, the missing coma, the unexplained acceleration, refuses to fit neatly into any box, and that has opened the door to a universe of theories, from the mundane to the truly wild. One leading idea suggests Oumuamua was a hydrogen iceberg, made of frozen hydrogen that would sublimate in the sun's heat, providing that mysterious push without creating a visible coma. Another compelling theory is that it was a water-rich comet whose ice was processed by cosmic rays over millions of years, trapping molecular hydrogen inside. When warmed, this trapped gas would be released, causing it to accelerate without a dusty tail. Other researchers have proposed it could be a shard of a planet torn apart by its star, or even a unique kind of comet made of nitrogen ice, chipped off an exo-Pluto in a distant solar system. And then there's the most talked about theory, proposed by Harvard astronomer Avi Loeb. It suggests we can't rule out an artificial origin. The idea is that Oumuamua's weird acceleration and highly unusual shape, perhaps extremely thin and flat, like a sail, could be signs of extraterrestrial technology. Could it have been a light sail probe? Or maybe just a piece of alien space junk tumbling through the cosmos? This theory is, of course, highly controversial, and most scientists favor a natural explanation. But the very fact it's being seriously discussed shows just how strange Oumuamua really was. It was a messenger, but the message it delivered was that the universe is far stranger than we ever imagined. So, who holds the ultimate speed record in our solar system? For a natural visitor just passing through, the new champion is 3I/ATLAS, with its peak speed of 153,000 miles per hour. But the true speed demon for now isn't alien at all. It's one of ours. NASA's Parker Solar Probe has reached a staggering 430,000 miles per hour on its journey to touch the Sun, making it the fastest object ever built by humans. But the probe's record is all about falling deep into our Sun's gravity well. The real test is an object's speed as it cruises in from deep space. And we are on the verge of finding many, many more. The Rubin Observatory is coming online, set to scan the entire sky every few nights. Predictions suggest it could discover not just one interstellar object per year, but potentially several, maybe even up to 10. With each new visitor, we'll build a library of other solar systems. We'll learn if our home is typical or rare. We'll find out what comets and asteroids are made of around other stars. And one day, perhaps soon, we'll detect an object on a trajectory so fast it shatters all the records again. It will be an ancient wanderer, a messenger that has traveled the Milky Way for billions of years, bringing with it the dust of forgotten stars, and the ingredients of worlds we can only dream of. The race to uncover its secrets will be faster and more frantic than ever before, and we will be ready.